Hey guys, in this video we're going to talk about how to add and subtract radicals, a little bit different than multiplying or just plain old simplifying. So when you're adding or subtracting radicals, one of the key things is that you need to have the same radicand to combine like terms. And what I mean by that is if we had, let's say, 4 root 2, so 4 times the square root of 2, and we had plus 7 times the square root of 2, that means in total we have 11 square roots of 2. So if you have the same radicand, you can then combine your like terms. Something like 2 times the square root of 3 plus 4 times the square root of 2, we can't combine these together. This is in simplest form because the radicands are different. You can kind of think of it like a variable. Over here it would be like 4x plus 7x is 11x. You have the same radicand, so you can combine together. Where over here, it'd be like 2x plus 4y. Different radicands, you can't combine them together. So our goal is going to be, when you have the same radicand, to combine them together, and then you'll be in simplest form. Sometimes you might have to do a little simplifying, like, let's say we had 3 and then radical 8. You'd have to simplify this first. They don't have the same radicand now, but this is not in simplest form because you could pull out, instead of radical 8, it would be 4 times 2. You pull the 4 out, you're going to end up with 3 times 2 is 6 root 2. So here you would end up with 10 root 2. So you have to make sure you're in simplest form and then check to see if you have the same radicand. So first slide, we have a couple of just recognizing and examples of how we can combine. So we have 3 root 6 plus 4 root 6. Notice the same radicand, so we can combine them together. This is the same as 7 root 6. And over to the right we have 12 times the square root of 3 minus 4 times the square root of 3. So you can subtract as well. Have the same radicand, so 12 minus 4 is going to be 8 times the square root of 3, and that's the simplified version in simplest radical form. Notice the two answers though, we could not combine those together. Those do not have the same radicand there, so they would not be able to be combined together. But in isolation, simplest radical form, simplest radical form. So let's move on to the next slide where it gets a little trickier than just checking. We have to do a little more work. Our first one, we have 2 radical 3 plus square root of 27. So for this one, our first term is in simplest radical form, but we need to simplify over here. Square root of 27 is like the square root of 9 times 3, and you can simplify that. That becomes 3 root 3. So we have 2 times the square root of 3 plus 3 times the square root of 3, so in total, we have 5 times the square root of 3. This is simplest radical form here. And let's color code. Our next one, we have 4 times the square root of 6 minus 4 times the square root of 24. So we're subtracting, so we need to try to find have the same radicand, so then we could subtract, otherwise we can't combine them. Our left term is in simplest radical form, minus, well, we can break the 24 up. What times what is 24? Are there any perfect squares? 4 is a perfect square, 4 times 6, which will end up with, you're going to end up with 4 times, take the square root of 4 out, so 2 times the square root of 6. So 4 root 6 minus 8 root 6, and you'll end up with negative 4 root 6. And that right there is simplest radical form. So sometimes you have to do a little bit of work. Just make sure each term is in simplest radical form. Notice with these you're adding and subtracting, so we're not using that property we talked about in the past because that's only for multiplying. So adding or subtracting, it's like terms. Alright, our next one, we have 3 root 8, and we are adding 4 times the square root of 18 minus 5 times the square root of 12. So first term, we can simplify a little bit. We have 3 times the square root of 8. 8 is like 4 times 2. So it's 3 times 4 times 2. I'm going to try and simplify them all in one step. 18, perfect squares that go into 18 are 9. 9 times 2. And 12, a perfect square that goes into 12 is 4. It's 4 times 3. So our first term, you're going to end up with the square root of 4 is going to come out. So you're going to have 2 times 3. You're going to have 6 times the square root of 2. Here your square root of 9 is going to be evaluated. You'll have 3 times the 4 is 12 times the square root of 2. And then your last term, the 4 is going to become 2 times 5. So you're going to have minus 10 square root of 3. Look for any terms with the same radicand, 2 and 2. The 3 won't be combined, but these 2 can be combined. You have 18 root 2 minus 10 root 3, and you're in simplest radical form there. All right, our next one we have in red on the same slide. And this one we have the square root of 20 minus 3 times the square root of 32 minus 8 times the square root of 5. So go ahead and try to simplify. Square root of 20, if you break it up, so that's the square root of 4 times 5. Square root of 32, perfect squares that go into 32, well 16 should jump out to us. 16 times 2 is 32. And the square root of 5, there's no factors of 5 that are perfect squares, so we'll just leave it as the square root of 5. In our first one, the square root of 4 is going to come out. It's going to become a 2 when you take the square root of 4, and you're left with just the 5 underneath the radical. Square root of 16 is 4. 4 times the 3 is 12, and you're left with a 2 underneath the radical. And then over on the end, we're just going to leave it as is. Look for terms with the same or like terms here. Your first and your last are 2 root 5 minus 8 root 5 is negative 6 root 5. And then you're going to have minus 12 root 2. They can't be combined, different radicands in there. And we're in simplest radical form right here. So if you're feeling okay with these, you can go ahead and try some. The last slide has 3 different problems, and I'll go through all 3 of those. And if you want to try them and check your work, feel free to do so. So our first one, on that last slide, we have 2 times the square root of 48 minus 3 times the square root of 12 plus 2 times the square root of 27. So your first step, I would simplify each term, try to get it in simplest radical form, see if there is any like terms that can be combined. So 48, try to think of perfect squares that go into 48. I know 4 definitely does. I think 16 does as well. Actually 16 goes in 3 times, so I'm going to use 16. 16 times 3. For 12, that one has been coming up a lot. It's 4 times 3. And for 27, a perfect square that goes in is 9. 9 times 3 will get you to 27. So now we can use that property we used to simplify the radicals. Square root of 16 is 4. 4 times 2 is 8. So it's 8 radical 3. Square root of 4 here is 2. 2 times 3 is 6. She'll be left with 6 times square root of 3. And then here the square root of 9 is what you're going to take out, and you're going to end up with 6, because 3 times 2 is 6, and you'll be left with radical 3. And notice they all have root 3, so you can combine all the terms. 8 minus 6 plus 6, well, minus 6 plus 6 is 0, so our simplified form is 8 times the square root of 3. That would be simplest radical form. Our next question we have in green. It is 8 times square root of 7 minus 7 times the square root of 28 plus 2 times the square root of 35. So our first term is in simplest radical form. There's no perfect squares that are factors of 7. So I'm going to leave that the way it is. Our second term, 28, there is a perfect square that goes into 28, and that perfect square is 4. So 4 times 7 will become our radicand instead of the 28. not changing the value, just writing it in a way that we prefer. 35, think of factors of 35, 7 and 5 would work, but neither one is a perfect square. We're not going to be able to simplify that radical, just going to stay as 35. So we need to simplify this middle here, and the square root of 4 is 2, so you can do 2 times 7, that's 14, and you end up with 14 radical 7. You're subtracting that. If you look for like terms, you'll notice your first two terms both have the radical 7, so you can do 8 minus 14, so you'll end up with negative 6 root 7 plus 2 times square root of 35, and there we go. There's your simplest radical form. We can't combine them together. They have different radicands there. All right, on to our last problem of the slide. We have 3 times the square root of 8 minus 3 times the square root of 20 plus 7 times the square root of 5 plus 2 times the square root of 18. First term we can simplify. 8 is like 4 times 2. There's your perfect square that we'll use. Our second term, again, we can simplify. 4 times 5. Our third term, we can't simplify that radical, so we'll just rewrite it. And our last term, 18, it's like 9 times 2. So here, 2, or the square root of 4 is going to come out, which is 2. 2 times 3 is 6. So you'll be left with 6 root 2. Here, the square root of 4 is going to come out, so you'll do 2 times 3, you'll get 6. And you'll have times root 5. Then we have plus 7 times root 5. And here you'll do the square root of 9, which will be 3 times 2, 6, and you'll be left with root 2. Our first term is 6 root 2. Any other root 2's? Our last term is 6 root 2, so we have 12 times the square root of 2. Our second term is negative 6 square root of 5 plus 7 square root of 5, same radicand. So we'll add them together. Negative 6 plus 7 is just 1. So plus 1 square root of 5. And there's simplest radical form for this. Alright, so go ahead and try to do some of these on your own of adding and subtracting our radicals. Have a nice day, guys.